Fadilah. I'll be giving you one example of the rule.
And I'm Riduan, and I'll also be giving you another example of the rule.
Let's go.
The Simpson's rule appear, or why the Simpson rule has been created. Have you ever came across questions where f of x with respect to dx, which gives you the area of a certain graph, would be difficult to get the exact value? A good idea will be getting an approximation, which is the closest actual value we can get from the Simpson's rule. The idea is to join the top of the strips to a parabola so that it will give you a more accurate approximation. What we must have is an even number of intervals. So you can see here is I drew few strips with y0, the first point, which is a, being the even, and yn, which is the last point, being even as well. In between, you will be dividing certain number of strips will be normally given in the question to get even number of strips. Okay, next we'll be seeing the formula. The formula here will be f of x with respect to dx will be h, where h is the size of the interval, the gaps, which will be upper limit, which is b, minus the lower limit, which is a, divided by the number of intervals, which is normally given in the question. And then h of this h, you will be dividing it by 3, multiplying the whole thing with the first height, plus 4 times the sum of the odd heights, plus 2 times the sum of the even heights, and finally the last height. Okay, let us take a look at examples to give you a more deep understanding about Simpson's rules.
For the first example, integral of square root 1 plus x squared with respect to dx with upper limit 12 and lower limit 0 and 4 as the interval. First of all, we draw a graph with any shape. In order for you to get the x, you have to find the size of the interval, which is the h. You take b, which is the upper limit, minus a, which is the lower limit, over the number of intervals. So it's 12 minus 0 divided by 4 and you get 3. So each of these is 3. Since there's 4 intervals, so put 3, 6, 9, 12. The first y-axis is even, then it's odd, even, odd, and the last one is even. After that, you sub in with the formula, which is 3 over 3. Then this is the first. This is the sum of 4 times the sum of the odd, 2 times the sum of the even, and this is the last. For the first is square root, you sub in the x to this formula, which is 1 plus 0, a square root of 1 plus 0 square subsequently, and you will get this answer, and you correct to 4 decimal place.
So this is our second example for today. The question is, estimate the integral of 1 over x plus cosine x with respect to dx with the upper limit of pi and the lower limit of 0 using only 2 intervals. So first of all, you draw a graph with any curve shape, because the curve shape don't matter. Okay, so second, you put in the lower limit, which is 0, and the upper limit, which is pi. Then you put in the strip, and this will be the 2 intervals. Then you put in the even for the first height, and for the second height you put odd, and the third height you put even. So in the middle it will be pi over 2 for the height. So using the formula, we sub in pi over 2, which is the h, the size of the interval, over 3 times the first height which is 0, we sub into the equation. So it will be 1 over 0 plus cosine 0. And we will add the sum of odd heights times 4. So it will be 4 times 1 over pi over 2 plus cosine pi over 2, since it has only one odd height. And since we don't have any even height in the middle, so we don't need to put the sum of even heights anymore. So moving on, we should just add we will just add the the last height, which is 1 over pi plus cosine pi. Make sure you set your calculator to radian mode, so then this will be your answer. You correct to 5 decimal place if it didn't state in the question how many decimal places are. That's all.
Thank you for watching. We hope you have learned something from this video.
Thank you and bye-bye.
Bye.